Alright, so here's the review sheet for Unit 8 on exponentials and log functions. So this right here, we have an exponential function because x is in the exponent. This would be exponential decay, right? Because this number is less than 1. So you're going to be decay whenever that b value is less than 1 or greater than 0. Growth is going to be when that b value is greater than 1. Okay, so like this right here would be a growth problem because the base of the exponent is bigger than 1. All right, the transformations. So the 1/3, I'm done with the 1/3. The 1/3 is just telling me how much growth or decay there is. So my rest of my transformations, I have this 4. Remember, that's my initial value. That's also going to be considered a stretch. So we get a stretch because it's bigger than 1. It'll be a shrink if it's less than 1. We're moving to the right 2, and we're moving down 5. Now, you have to remember that your original growth or decay, or basically your original exponential function, growth is going to look like this, and decay would look like this. So both of those have asymptotes. Like your original asymptote of an exponential function is at y equals 0, right? All right, so you have to ask yourself, like, how does that y equals 0 get affected? It's a horizontal asymptote, so it's going to be y equals, and if something's right here and you move something to the right or stretch it, it doesn't do anything. But this down 5 right there, this number out here controls the asymptote, so y equals -5. Everything past that, so you could go ahead and draw, y equals -5 on here. And everything past that, you'd probably want to go to Desmos and graph it. So something a little bit, so I have it on Desmos here. So something a little bit weird on Desmos is that when you go ahead and put in, it's kind of hard to see, sorry, when you go ahead and put in that exponent, you got to put in parentheses because it wants to hold it together. So anyway, so if I just turn that on, here's my picture. So I can get the x-intercept is 1.8, let's say. So 1.8 and 0. All right, my y-intercept, I'm going to have to go all the way up here and click on it. There it is. It's 0 and 31. Whoops, I lost it. All right, so 0 and 31. You can also get your y-intercept by literally just plugging in 0 here and doing the calculation. All right, sketch a graph with the asymptote. So let's go ahead and put those things on there. I'm not going to be able to get the 0 and 31, but 1.8 I can show about there. And, the graph was basically, coming down like that. So it's coming down close to the asymptote. It's rising on up. I'm going to get closer to the y-axis, but I'm not going to touch it yet because it's supposed to touch at 31. Okay, and, this comes close to the line y equals -5. So my domain. The width of my graph, goes right forever, and this is going to go left forever. So my domain is -infinity to infinity. All exponential functions have that. My range is controlled by this asymptote right here. So, did you crack it? Oh, dang it. Sorry. Let me see if I might have an extra, cup. Let me see. Yeah, it just dropped the right way. I feel like somebody recently gave me it, but
Only also break up off.
I thought I had like a bug or something that came on me. No, sorry. May I have a cup? You want to pour your water in a cup?
Oh, glass cup? Oh, mine. Sorry,
I have like a solo cup.
Is that what we use all the dice for?
I mean, I will give you a different one. I'll go deep in. I did put them back.
So here, I'll give you one of these.
Yeah.
I feel like you can
Maybe just empty it out a little bit. Oh, sorry. Well, now you get to buy a new one. this is like special water. I don't know. All right, sorry guys, you can just fast forward past that there. So your range is gonna be from this asymptote up, right? So from -5 up, but you're not touching -5. So -5 to infinity. All right, so this problem here. So remember, exponential functions right here, this is the asymptote back there. So it's gonna be, because this is gonna be basically a growth problem, it's moved to the left 7, but it's moved down 14. So this down 14 is going to make an asymptote down here at -14, at y equals -14, okay? So that's opposite of a log function. You know, your original log function looks like this. It comes up like this. And you can also graph it on Desmos, but it has an asymptote at x equals 0, all right? So this graph is going to get moved to the left 20, but it's going to get also moved down 17. All right, so what's going to happen is the 20 is the thing that's going to move the asymptote. So x equals 0 changes to x equals -20. Okay. All right, over here, what's the 0 of this problem? So the 0 is what makes this equation equal 0. A 0 is an x-intercept. So for that problem, I'm just basically going to put it into my calculator or Desmos. I'm going to graph it. What is it? 5 to the x minus 45. So it's an exponential growth problem, and it's been moved down 45 spaces. So 5 to the x minus 45, right? So, and then I would see my x-intercept right there, 2.37. So 2.4, 2.37, whatever you want to say. All right, down here to solve this equation, I have to think of, these both have exponents over here. So I have to think to myself, how can I change these to match? So it's just a special case, you know, sometimes you can't change them to match, but in this case, and the ones I'm going to give you, you can. Like 16 and 8, they're both powers of 2. Now 16 is also 4 squared. So, but 8 is not 4 to a power, so I can't use the 4. So I know that 16 is 2 to the 4th, and I know that 8 is 2 to the 3rd. So I'm going to change it to that. So in place of the 16, I'm going to put a 2 to the 4th, and that 3 minus x is going to stay. And in place of the 8, I put a 2 to the 3rd, and then the 2x stays. So now with our exponent rules from Algebra 1, you know, I multiply my exponents. I have 2, I'm going to multiply this 4 times both, so I get 12 minus 4x. And over here I get 2, I get 6x. So now the 2's are not really important to me anymore. I know that 12 minus 4x has to equal 6x. All right, so I've got to solve that. So I add 4x, I get 10x equals 12. So my final answer will be x equals 12 over 10, and that changes to 6 over 5. All right, so final answer, or 1.2. All right, on the back side, we've got a log function. So remember, like I was saying, a log function normally looks like this. It comes up through here. All right, it crosses at the point 1, 0. All right, it has an asymptote of x equals 0. So this is going to get moved around, right? And the transformations is going to get moved to the left 3 and down 1. So which of those things moves this line? Well, left 3 does. So the left 3, that means my asymptote is going to be x equals -3. This is what's controlling my asymptote. And then the down 1, if you shift this down 1, like you don't really care, like it's just not going to move the asymptote. All right, so x equals -3 is here. And if there's no stretches or anything like that, then you can kind of track this point. Remember this point 1, 0? So 1, 0 is going to move to the left 3, 1, 2, 3, and down 1. So it's going to be like right there. So, you know, but for the rest of the graph, I would go ahead and put it on Desmos. So to get a log, you could just literally type the word log. All right, so here's what this picture looks like. All right, and I can see I have an x-intercept right there at 7. That's a 0. And the y-intercept over here at 0 and -0.52. Okay. All right, so I will try to repeat that right here. There we go. Oops. Sorry, wrong way. All right, so negative 0.5 is there, 7's over here. So it takes a while for it to come up and touch the x-axis, and then it keeps going above it. All right, and this comes down here, right next to the asymptote. Okay, so as x goes to negative 3, as you come in to negative 3, the graph is going down to negative infinity. And as x goes to infinity, so as you go over to the right, this graph is slowly rising up, so it's slowly going up to infinity. All right, these next two problems is just practice with our log form and exponential form. When something is an exponential form, you know this is your base, so you say log with base 3. I usually like to leave a little space right here and put an equal sign because this is my base. My power goes over here, so 4. And then the answer, 81, goes right there. So if you ever wanted to check that, you could go into Desmos and you could type in log base, right? So you could type in, you could go to the function button, and if you go down towards the end, I think, there it is. There's a regular log, or you can type log, but you can also do this log, which is with a special base. So you can do log, this is base 3, and then go over here and put in 81, and then you can check and make sure, yeah, so it equals 4, right? What we wrote. All right, so over here, remember, base, power, answer. So the exponential equation you would, that this turns into would be 5 to the third equals 125. And that's true, like it has to make a true statement. All right, so here. So in this kind of problem, we have some data that we have to put in. So I have already put it in here, you know, to put in this table. I went ahead and I pressed the plus button and I pressed table, and then I put in the numbers. Okay, so I'm going to turn it back on. So, I mean, these numbers are getting very large, so I can tell that it's growing. So if I zoom out, you know, you start to see the things. It's actually hard to tell, but anyway, they are getting higher and higher as I go out to the side, right? Because the scale is getting messed up. But this is exponential growth, right? Because the answers are getting bigger. And to make the Desmos do a calculation for me, to do an equation, a model, press these little buttons up here, and then I get my choices. So I'm going to go ahead and choose exponential regression, and there it is right there. So I got 598. So I got y equals 598. So basically this equation here, all right, times, and I got 1.1, I'll say 1.19 to the x, right? And so now I need to predict what's happening at 12. So what you could do, I can't really do it good here. So on your computer though, you could cut and paste this, like take this and then you're going to plug in a 12 there. For me, I'm just going to enter 598 times, and I'm just going to enter what here and put a 12 there, but you could cut and paste if you want. 1.19 to the 12. Okay, so look, I'm going to have 4,822 bacteria, right? Right, because that's what this problem is about. It's going to grow to that much, and that's what I expected. You know, it's getting higher. All right, on this next problem, this is like that paper we did in class with the circuit training paper. Just a little problem from there. It says you are studying the effects of chemical bacteria. You have observed that the chemical is killing off 20% of your bacteria. So if it's killing off 20%, that means you're keeping 80%. So your equation, this right here, is P of T equals, you're starting with 1,000, that's your A value. If you're killing off 20, then you're keeping 80, so 0.80 goes right here, or 0.8, and T there. So there's your equation. And we want to know when it's going to reach just under 55. So I have to keep trying numbers right here. I'm just going to do it in my calculator because it's a little easier. All right, so I got 1,000. Oh, you know, I did it already. So if I type in 13, like I was trying some numbers here, so 13 is going to be just under 55 bacteria. So I would tell you it's going to take 13 hours. Okay. All right, that's the last problem here. So if you have a log equation and you equal to a number, just like we changed this log to an exponent, that's what we're going to do. So I can take this real quickly and I can change it to an exponent. So 8 to the 2 has to equal that right there. So 2x minus 1. So I know 8 squared is 64. And this just becomes an algebra problem I'm going to do. Right, I'm going to add 1 to both sides, so I get 65 equals 2x. And so my answer would be 65 over 2. Or 32.5. Okay. All right, so that's it. See ya. Bye-bye.